Excellent. Well, thanks everyone for joining us. This is kind of an interesting webinar. Most of our webinar series is about doing analysis in JMP and using JMP as a teaching tool and showing, students concepts. This is actually on the other side of the table. It's really about how you're going to manage and work through sort of the course grades that you accumulate after teaching your stats course. And so today's webinar is a lot about data management, which is actually a general purpose skill that's actually really great when you're working with your own data. But when it comes to gradebooks, there's this couple very specific things we all have to do. And I remember when I first started using JMP for my gradebooks, it was really surprising to me that I hadn't done it before. I've been teaching with JMP, but I hadn't thought to use it for the course grades. And so I hope after today you'll be able to transition your course from certainly Excel or Campus CMS or whatever method you're using to store your grades into JMP and get some value from it. And so let's take a look at what topics we're going to cover today. Now on the management side, what I want to show you how to do is some of the basics, so importing and exporting from CSVs or from your campus CRMs. How to merge in columns, right? So when we get new grades for new assignments or when TAs send us new grades, how we actually add those into the standard gradebook that we're managing throughout the quarter. I want to show you some tools that are useful for detecting errors. So these could be errors in entry. So if you're actually having people hand enter grades, of course, there can be errors. These can also be errors due to grading failures. Maybe something happened with the version number on a Scantron form that a student entered. And so being able to detect those errors is really critical. For research data, an error might lead to a misunderstanding of some relationship in the world. For campus grades or for student grades, an error might lead to a bad grade for a student, something that they actually deserve better. And so these errors are very important to capture. I'll talk about calculating new variables. So this is something we have to do pretty much in any grading circumstance. From the simplest versions of this, creating averages at the end of a quarter, to standardizing and to dropping scores. So I'll show you how to calculate those variables in JMP. And then finally, some special tools in JMP that help you manage your data sets. And so the organization of the data set, I find actually is much better in JMP than anything else, even Excel or the campus CRMs. JMP is built to handle very large data sets, and sometimes for our data sets with grades, we actually have a lot of scoring columns. So I'll show you how to manage those. So that's on the management side. Now the other side of things I want to talk about that JMP is useful for is on the assessment side. And so there's one type of assessment that we'll talk about first, web-based assessment. So we actually partner with WebAssign. So there are some assignments and questions that actually use JMP output on WebAssign. So if your campus or you have a license to WebAssign, you can incorporate these in your course right away. Now, the other thing I want to talk about is when you're working with especially large classes and you want to individualize data sets for a take-home or for some kind of assignment. And this is especially useful for the higher stakes, let's say a midterm or a final, when you really want students to be working alone and you want them to all have different data and different answers, but you want to collect those answers and you want to grade them in an efficient way. And so I've done this in classes, as big as 300. So every student getting their own data set for a final and having totally different answers, but, not creating a management nightmare on my side for having to grade. So I want to show you a method for doing that in JMP. Okay, so let's get started here with the management side. And before I show you any of these tools, I want to show you where we're going to end up. Now for a large class, and don't worry, every student grade I show you today, these are anonymized. These actually are not their names or their IDs. But the grades that I'm going to be using actually come from several different classes that I've taught over the years. But they're of course detached from any name or recognition here. But where we want to end up with today is a data set for either your big or your small class, where what you have is probably a number of different columns that aggregate the students' grades. And so you'll see on the left here, I have a columns list. And if you're new to JMP, don't worry, I'm going to take you through the basics as I go along. But you may not be familiar, even if you've used JMP, with things like grouping columns. So here I have all the different homework assignments, the different midterm scores and participation points. So this is actually a rather large number of columns to manage, and you'll see some are excluded and hidden. And so these are all tools I'll talk about today. But what eventually I want you to do, and what we all want to do with our grades is, start with all the scores, then end up at the very end with that final letter grade that we have to give them or upload to our campus. Right? So we have to take all that information and aggregate it down to some final little letter. And so that's what I want to help you do with JMP. And I definitely find it to be a much more useful way. So let's actually step back here. I'm gonna close that, and let's actually start with the most basic question. How are we going to start off this gradebook? And really it comes down to taking your campus roster or your CRM, so the campus management system for student grades, exporting out some kind of roster to start your data set. And I'm going to simulate that here. So I've imagined that I've pulled down the class roster from either my campus management side, or somehow I've gotten this. And what I want to do is open it in JMP and start off making my base data set. Now, you probably noticed if you've JMP before that it's as simple as doing file open to open up a CSV file. That is, we can just point our JMP open to that directory, and I can just double click to open this. And JMP does a very good job guessing what the delimiters are for the columns. In this case, it's a comma, and guessing what the sort of the organization of that data set is. And notice that there was file names or column names, and it noticed the number of rows. So I can just click next and import. Now, that import wizard that came up will help you if for some reason your campus CRM exports out a bunch of sort of basic rows at the start that maybe aren't data, so you can specify where the data start. But this is our base data set. This is our class roster that just has the IDs and the names. And you'll notice there's actually a source script written to our data set. So I'm going to show you how to write scripts to the data table that is useful for grading purposes. But what this source script does is if I click the play button, you'll notice it opens up a copy of the data set. It's just a script that actually writes out the import routine we just ran. But I don't want that in my data table, so I'm just going to right click and delete this here. And so there's our base data set. Now, my recommendation is don't rebuild this every time you want to look at grades. We're actually going to do file save here. And I'm going to save this out as my class roster as a .jump file. And I would encourage you to keep actually a JMP file of your class roster. Even if you maintain grades online, keep a version of it on your computer that you'll be updating. And just a basic practice here with especially important data, I would give this a name and a number, or at least a date. So I would say this is 2016-11/30. And so my naming convention looks like that. And so I would keep a version of this every time you update data with the class. And the reason to do that is if for some reason anything gets messed up, like you overwrite some data or your campus CRM overwrites data and you're updating the same file, you'll always have backed up versions of it. And that's a really good practice for very important data. All right, so that's our basic data set. Now, if we needed to export this out and upload it to our campus, like Blackboard or Canvas, file export on the Mac is how you'll be able to export a CSV. On the PC, it's file save as. I'll just do it on the Mac here, file export. And notice I have a lot of options. If I want to export to a CSV, a comma separated values data set, that's text. I just click next. JMP will ask you where to save it and what the delimiter should be. The delimiter meaning the end of a field. So the comma is the most common here. And JMP's default is a DAT file. We can just call that a CSV. And that would save this out as a CSV. I'm actually not going to do that because right now we just want to keep this in JMP. But that's importing and exporting, fairly straightforward in JMP. Now the next thing we're always going to have to do is append or add to this base roster the grades we get from students. And so there's a number of different tools in JMP I want to talk about, and they're useful for different circumstances. The first will be tables update. So this is the update option here. We have tables join. So joining tables. Now these do slightly different things, and I'll talk about what those things are. And then a new feature in JMP 13 called JMP Query Builder, which is very useful when we're building a table with many new columns all at once. So I'll show you how that works. But let's try the most basic one, tables update, which is useful when what we're doing is adding new grade columns. So let's say we just got homework scores for the students, or we're updating existing data with new data. For instance, let's say we got revised grades from our TA who realized that they missed a couple answers on everyone's homework. Well, let's start off with the first case. We're going to add some scores to this data table. And so I'm going to open up this homework 1 CSV. And notice that when I open it up, it'll pop into this little JMP window, and I can import these as data, just like we did before. If I had done file open, it would have imported just like this. Now this homework 1 has the actual score column and what's called a linking column, or a column that's going to be able to attach or match with our original class roster. And this is really important to have. Now it's either going to be a student ID or a student name or something that identifies the individual rows so that JMP knows how to bring the data from one into the other. Now the nice thing about having a linking or a matching column is that we don't need to worry about the row order. Now, oftentimes we really will have the rows in the same order. You'll notice they are in this case. But what if many students drop your course? So halfway through, you have a different number of rows even with the files you're adding. So having a linking or a matching column allows JMP to do the work of matching the rows and bringing in the new scores. All right, let's see how we're going to get those homework scores into our original master table. So again, go to Tables, and we're going to use for this one, Update. Now Update, what it will do is ask us which table do we want to add into this table we had selected. Notice I started by clicking on the class roster table. That was my active table. And so it's asking me, I want to update class roster with data from where? Well, I'm going to do the homework 1 table. Now, if I just click OK, what JMP will do is copy directly over as if all the rows are in the same order, which actually in this case is the case. But let's not do it that way because I want to show you the much better practice, especially when we're using tables that aren't in the same order. I'm going to click Match Columns. And what this says or asks is which column in this first data table, the class roster, matches with a column in the other data table. And in this case, it's the student ID columns. I'll select student ID in the first table list. So those are the columns in the first table. I'll select student ID in the homework table, and I'm going to click the match button, and this sets up the identity. Notice I can match on multiple criteria. If we only had first and last names, I would say last name equals last name match and first name equals first name match. So we can do this multiple column identity. In this case, student ID matches perfectly with student ID. Now, let's look at some of the other options, especially over here. JMP's asking me to add columns from the update table. Do I want to add all of them, none of them, or selected columns? Let me click on selected, and notice JMP tells me or gives me a list of which columns I can potentially add from that update table. Well, I'm going to click all, and let's just leave it on the default, and I'll click OK. And let's see what happens. Well, notice what JMP did. It took this homework 1 column and stuck it in my class roster. And it did it based on the matching criteria. That is, I didn't have to have these tables in the same order, which is the really powerful thing about update. Now let's look at another use of update. That is the updating of the existing data. So let's imagine that my TA just sent me homework 1 updated. That is, they said, oh, sorry, we missed question 4, and here are the new grades. So these are going to change for each student. Well, I could just copy over all the new grades, but maybe my TA only sent me a subset of these. Maybe he said, actually, only the first 10 are updated grades. And so let me delete all the rest of these. And so these 10 are what I need to update. And maybe it's not the first 10 rows in the table. It's just 10 scattered throughout the course. Well, we can use update for this as well. So if I go back to Tables Update, it says, which table do you want to update data from? Well, homework 1. We're going to match. And again, we're going to match on the basis of that student ID. I'll click the 2, click match. And now when I click OK, JMP will search through this table for values found in the update table, and it'll update the rows with the proper data, so the new data that we just gave it. And so this is a very powerful way to add in new data, especially when something has changed in the original data. So that's how update works. And update is probably my go-to when I'm adding in new columns, or especially when I'm updating data. But let's look at join. Join is a slightly more powerful version of update that can certainly do the updating, but can do a great deal more. And so I open homework 2. So homework 2, I want to add into my original table. Let's go to Tables, Join this time. We could think of this as the big brother of update. Now, we have a lot of options. Don't worry about those yet. First, look at what JMP's asking me. It says, join my roster table with what? Again, we have to select a table. And so I'm going to say homework 2. In the source columns, notice we have an option to select columns that can match. Again, student ID will match with student ID. And so I can click those 2 and click match. Before going any further, notice that there's this matching specification. So I can match by a matching column, which is what I did with update previously. But if I click this, notice there are some different options. I can update by row number, which literally just says first row is equal to the first row in the other table and moves the data over. Or a Cartesian join. This is kind of a special type of join where each unique observation of one table is joined across the levels of the other. We're not going to be using that one for this type of join here. So leave it on by matching specification. Don't worry about the top yet, but look at what's happening in this lower section. This is the section where you can control what JMP does with the observations it finds. And the default is what's called an inner join. That is, it will look for observations that match in both tables, ignore everything else, and build a table that has just the matching observations. That is, the times where student ID was found in both tables. That's called an inner join. Now let me click Include Non-Matches for both of the others. So with the main and width table. The main table is our master JMP roster, and the with table is that table of homework 2 scores we just opened. So a full outer join will include all the IDs it finds, whether or not they're in both tables. That is, it'll include times when the with table, that is homework 2 scores, included an ID that wasn't in the main roster, so a new student who added the class, for instance, or it'll also include observations that were in the main table but not in the with table. That is, somebody who didn't submit a homework 2 score. That's usually what we want, because then we'll actually be able to see all the scores. Now we have things like a match flag and merge same name columns. These are some additional options that you can play with later on. There'll certainly be Mastering Jump webinars that'll go into join in a lot more detail. And we're going to come back to this in a second for working with what I call a fuzzy join in a little bit. But let's just do this for now. I'll click OK. And notice what Jump will do is build a new table here, including both new columns that are in the original homework 2 table. That is, it got us the student ID of homework 2 and the homework 2 scores. Now notice Jump did something that I actually just prefer. That is, it put in the matching column from both tables, and it built us a new table rather than just adding to the original table. And I don't like doing that because I really like having a base table that I'm just adding scores to. And so my preference is actually to use tables update for these types of joins. Notice that you do have the option in join. Let me recall what I just had, to merge same name columns. That is, columns that are the same name, like student ID, will simply be merged. And we do have the option to update the main table with data from the second table. So just kind of like what update does. But notice that join is a little bit overkill for our purpose. Tables update does a really nice job adding in new columns from new data. So that would actually be my preference. All right, so that's tables join. Let's look at a new option in Jump 13, which I find very useful for a situation we find ourselves in here, which is Jump Query Builder. Now, Query Builder, in addition to doing what update and join can do, can actually support multiple tables at once. And it does this through a little bit more interactive of an interface. And let me show you why this is useful. Suppose we have, and we do in this case, have 9 homework scores. That is 9 separate tables. I'll open them all at once here. 9 separate tables that all have homework scores. Now we could go through the process of doing tables update for each one of these, and that is something you can do. But instead of doing it that way, let's actually build a combined table of all the homework scores and the class roster. And we can do this all at once. So under Tables, Jump Query Builder, which is new again in Jump 13, this launches what basically looks like a database interface. And what it's asking us for is a primary table and a secondary table. And so the primary table is the class roster. That's our base roster of all the students. And the secondary tables are the homework tables, so 1 through 9. And I'll add those homework 1 through 9. Now, what this lets me do is when I click Build Query, I can specify what columns I want to have added into the final table and how I want to work with them. And Jump's going to automatically do all the linking. And so certainly I want the last name, first name, and student ID. Those I definitely want in my table. And notice it's doing a little query preview for me. But I also want the homework scores, homework 1 through 9. And so I'll select those all on the left and click Add. Notice that I don't need the ID columns from every separate table. Those don't matter because I have the student ID from the main table, and that's what's actually being matched to all those columns. And so what I have here is actually the table I want built. That is the homework scores plus the first name, last name, and student ID. So notice when I click Run Query, this builds me this table all at once. And so without having to do the tables update repeatedly, what I've actually built is my table of all the homework scores. And if I want, I can do something clever here. Notice the homework scores are a little bit out of order. I actually have 2 homework 1s since I added it twice. I'm going to do something simple here. I'm going to click this red triangle for columns. I'm going to reorder, and I'm going to order by name. And so it actually does this 1 through 9. And I'll take this last name and first name and stick them back at the front. And so this is actually now my main table. I've built it now with all the homework scores all at once. Let me close out my original roster. And I can now resave this actually as my new table. Now, this type of join, when we're doing this as a query, is very fast, which is great when you're actually adding in all these columns at once. But most of the time, you're actually getting your scores from the campus all at once, or you're getting them 1 week at a time. There isn't really a time where you're going to be 9 homeworks behind schedule with updating your table, or at least I don't think you should be. So let me actually save this as, and I'm going to save this as my class roster and overwrite that first one. All right, so that's Tables Query Builder. But let me show you a situation that I don't know if you've had before, but I came across a lot of times, especially in large classes, where what we're working with is basically scores from a Scantron or some type of exam where the students haven't done a very good job bubbling their scores. And so just for an example here, I'm going to close class roster, and we're going to work with some hypothetical side data. Let me pull up in two tables, so exam 1 and exam 2. And what you can actually see, or what will happen, is if I join these tables, some of these students have not actually bubbled their scores correctly. And just to show you this, let me do a join, and I'll update exam 2 with exam 1. And I'm going to include the non-matches. Remember, if I do this operation, then JMP will actually include the observations that are unique in each table. So I'm going to match by student ID again, and I'll click OK. And notice that even though there are 246 observations in exam 1 and 246 in exam 2, this final table has 261 observations. That's a problem. And what you'll see is that there's this big clump in the beginning of student ID of exam 1, these exam scores here for exam 1, where that didn't match to anyone in exam 2. That is, those IDs didn't match. Similarly, if I go to the bottom, you'll see some spaces here, places where there was an ID for exam 2 and a score for exam 2, but no ID or score for exam 1. And so these are students who have bubbled their IDs slightly wrong. And I found that I get about 10% of these per exam. And this could be kind of annoying. And so what we're going to use is some of sort of the logic in JMP and a little workflow that I came up with to do what's called a fuzzy ID match. So a match that actually allows us to give a little tolerance for when we join. So let me show you how this is going to work. And here's our workflow on the left. So we're going to use join, we're going to use recode, and we're going to use summary. And so let me show you how these all unfold. So first, tables join. And what we're going to do is join this first table with the second. We're doing a matching column. We're going to match on ID. Now we're going to do something special here. We're going to do a full outer join. That is, we're merging or including matches from either table and non-matches. So that full outer join. Then we're going to select something here of merge same name columns. And what this will do is stick those ID columns from the two tables actually into a single column. And you'll see why that's really important. So I'll click OK. We get our table with 261 observations, again, because some of these IDs matched and some of them didn't match. But now we're going to use a really great feature in JMP called the column recode. And column recode, column here, recode. If you have JMP 12, it's actually under the utilities submenu. So if you're in 13, you'll see it here at the top, column recode. And we're going to recode this student ID column. And notice what recode does is it shows us all the values in the column. But what we want Recode to do is look for values that are similar. And this is a new feature now in JMP 13. So under the red triangle, we're going to, the JMP 12 had this, under the red triangle, group similar values. And when I group similar values, what JMP will bring up is this option. It says, what can I ignore to make one of these IDs into the same value as the other ID? And certainly we can ignore case and printable, non-printable characters, punctuation. Those are really good for normal text. But it's this allow character edits that I'm interested in. That is, we can allow a quarter of an ID to be different from another ID and to group them. Now that's pretty extreme. If somebody actually just has a very similar student ID to somebody, that may capture it. What I'm going to say is there's a maximum character difference. That is, a student can be misbubbling 2 of their ID numbers. That is, they can put in something wrong, and I'm going to have it tolerate that to be the same. So I'm going to leave it there and click OK. And I'm going to check this box, Show Only Grouped. So what JMP is showing me now are the IDs that were just 2 or fewer numbers off. And notice that I can go through this list, and this is what I actually do with my actual grades. I would go through and figure out which of these 2 is actually the correct ID. JMP just chose the first one it came across as the new value here. That is, it'll recode this to new. And so what I would do, my workflow at this point, I'd go back to my roster and actually check. I want do that for you now. I'll spare you the time. But let's assume that we've gone through and actually put in the right ID for each of these matching ones. I'm going to go to Done, and I'm going to recode in place. And what this will do is write over that student ID column with the recoded ID. That is the ones that were just a little bit different from each other, and we chose which one to recode to. It's now written over. All right, so now we still have these blanks. That is, we still have not actually created a data table we can merge back to our original. That's because those rows, there's actually two for a couple of these, some for exam 1 and some for exam 2. So here's the final trick. We're going to use a feature to get this into a new table that basically chooses which exam 1 and exam 2 column to use. Let me show you how this is going to work. I'll go to Tables. We're going to use an option called Summary. And Summary is great for performing averages, sums, whatever we want under statistics here. What I'm going to do is say, build me a table that has as its rows student ID. And what JMP will do is when it sees a student ID that is the same in two of the rows, which will occur because we just recoded them, when it sees the same, it has to operate on the values from exam 1 and exam 2. And I'm going to say, choose the max. That is, look through the table. When you see an ID that matches another ID, and one will be a blank and one will be not blank, just choose the maximum and put that into a table. And watch what's going to happen. I'll click OK. The table that was once 261 rows because we had the people who bubbled wrong, now we have 246, the right number of rows that we had in the original tables. Because what it's done is gone through, and when there were 2 rows for a particular student, that is, they entered it differently on exam 1 and exam 2, it just pulled the values that were actually the correct values there. And so we've now recoded and done a fuzzy match. So this is the table we can update against when we're building our final gradebook. All right, so that's using tables join, recode, and summary to do a fuzzy ID match. And I'll definitely have this video available and this journal available so you can follow along a little bit slower with your own scores. Once you've done it a few times, it's actually pretty straightforward. All right, so let me close this sort of example side table. Let's get back to our main table that we were building. So I put this over here, the class roster. So there we go. All right, so we put all our homework scores in here. Before we leave this section, I had a couple other tables I want to add in really quickly. And so I'm going to do the final exam, midterm 1 and midterm 2. And so let me bring these in. Now we could do this as a tables query builder, but just to show you the usefulness of each of these other ones, I'll do tables update for this one. I'll update with the final exam, match on student ID, bring that in. Let's do one for midterm 2, so tables update. So match with, let's do midterm 1, I guess, first. Student ID, student ID. So you see how fast you can get at these tables update. And let's bring in that midterm 2. Match columns, student ID by student ID. All right, so now we have those in. So this is so far a data table that presumably could be actually all the scores that we have for a quarter. And so our midterms, our final exam, the raw scores that is, and then our homework scores, each of the raw scores for each of the different assignments. All right, so now that we've imported and merged, let's work on detecting errors. And I just want to point out a few methods that we use just generally in JMP for detecting problems of entry. And certainly the univariate options are the most straightforward. Univariate being looking at the distribution of these variables. And so what I mean by that is going to the Analyze menu and literally using distribution. So the platform that's all about looking at the univariate characteristics of a column. And let me take a few of the homework scores, and I'll take the final exam, midterm, and midterm 2 scores. I'm going to click them into Y and click OK. And again, if you're new to JMP, distribution is really the best place to start with any data set, just to get an idea of what data you have. And notice that we can already see that some students didn't compute or didn't take homework 1, so all the zeros there, but the vast majority of them really well. And so student grades actually give you a lot of insight into your assignments. When I built these homeworks, I built them to be essentially proficiency. And so they can take them to mastery, and so most students do extremely well on these. They're not meant to trick them or anything. For final exams and for the midterms, you see our distributions are a little bit more, at least symmetric. Certainly we have some long tails. But what we're looking for here are really strange points. And so the students, the clump of them getting zeros here, those are certainly, at least I know this to be the fact, students who added the class late. And so maybe I want to mark these students in some way. Maybe I want to reach out and give them an extra assignment because they joined so late. There's some tools that we can actually use in really any platform in JMP. Things like setting row states and naming selections. I want to show you my favorite. Once we grab those observations, I can right-click, and I can do this name selection in column. And so what I can do is give a column name for a new column JMP is going to write. I'll say added late. And I'll give them a 1 for those that I have selected and a 0 otherwise. So when I click OK, notice JMP will write a new column to the table that then I can use to select rows by. So I can right-click on the ones and say select matching cells. Right, so if I want to grab all those students and maybe send them an email for them some other assignment. Right, so that's one way we can look at these distributions just to see if there are strange observations. When we look at things like final exams, well, people who are getting in the 20s, maybe these are students that I need to reach out to, or in the midterms. This idea of looking at the univariate distribution to find unlikely observations. And certainly you'll have students who score very low or very high, but the great thing about looking at the histograms is it's very obvious when there is a very large error. If every student is getting between 15 and 25, and you have 2 that scored a 3, then you'd be able to note that there's something strange about those observations. All right, so that's univariate outlier detection, so looking at the distributions of each variable. Another one I want to point out is multivariate outlier detection, and this is one I really like, especially for exams. Exams that have a lot of good information and you would expect have high relationships to each other. And so this is under Analyze, Multivariate Methods, Multivariate. And what's valuable about this is, let me take my exam columns, exam midterm 1 and midterm 2, so the final and the midterms. Click OK. We'll get scatter plot matrices, so looking at the relationships among these, and we certainly expect them to be correlated. They shouldn't be perfectly correlated. Hopefully exams are capturing different attributes or testing on different things. But what we can use multivariate for are finding observations that really don't make sense. That is, students who do really great on certain exams but really poorly on another, or really poorly on all of them except for one. And so the great tool I want to point you to is under the red triangle. It's under Outlier Analysis, and it's called the Mahalanobis distance. And I use this before really any multiple regression. It's my favorite multivariate outlier tool. What a Mahalanobis distance does for us is it produces this little plot. And what we're looking at on the x-axis is the row number. And so the first section over here is the first, in this case, 7 rows in the table. And this is the last row in the table. So that's just the row number. But the y-axis of this Mahalanobis plot is actually showing us a distance measure. That is how far from the centroid a point is scaled by the covariance structure, which is just a fancy way of saying how distant it is and how distant is it in a strange place. That is outside the center ellipse or around the centroid. And so if I grab the highest point, that is the most extreme Mahalanobis distance, and actually let me grab the top 3, those 3. Notice that they're all kind of falling outside the ellipses here. They're in strange locations. If I turn on a 3D plot, so the ellipsoid 3D, you can see that they're the ones that are outside the ellipsoid. And so they're just in a strange location. Now, what do I mean by a strange location? A great way to see this is under the red triangle. I'm going to turn on the parallel coordinate plot. And what the parallel coordinate plot does is it's showing us for each column we're using, so final exam, midterm 1, and midterm 2, it's showing us the profile of each student. So I have 3 students selected, so we're looking at 3 different profiles. And let's interpret this. So this top line here, this student scored really high on the final, so near the top, that's what it means to be high on this axis, but really low on midterm 1 and 2. And so that's a student who either worked really hard to learn the class or cheated really bad, or cheated really well, I guess it is. So this student did really poor, then did really well. I can actually tell you, since I know this student and these, again, real data but false names, that student worked really hard. So they pulled their grade completely around. But that is a very strange thing to do relative to all the different observations we had. That's unlikely. Now, the others are also concerning. These are students who are doing very well, but got near the bottom on the final exam. Well, I could tell you what the students were doing. They bubbled their IDs wrong, and none of the TAs caught it until I did this outlier analysis. And so those students would have actually done really poorly or gotten a very poor score, and certainly would have come up to me after the quarter was over, but we of course caught this before. Again, by doing outlier analysis and looking for these multivariate outliers, they didn't even come up as too extreme in the univariate outlier detection because they're, at the bottom. Some other students actually did do that poorly, but these students, it didn't make sense to do that poorly. And so that's a Mahalanobis distance. So a great way to find those unlikely observations. All right, so that's some just sort of detection of errors. And so I highly encourage you to look through your scores and certainly before you make final grades. All right, so speaking of making the final grades, we're going to have to calculate some new variables if we're going to want to get that final letter grade out of this. And so we have a couple needs. Certainly averaging assignments. I want to get an average of my homework scores. Maybe dropping the lowest score. For this class, I actually dropped the lowest 2 homework assignments percentage-wise. Maybe we want a standardized score, so maybe we want to z-score some of these observations, and I'll show you how to do that. And certainly we need to build a final letter grade. And so the great way to do this in JMP is using the JMP formulas. And hopefully if you've never used JMP before, this should be new obviously, but if you have used JMP, I hope you know you can right-click on a new column and go to Formula, and you can define a formula using the formula editor. And it's as simple as taking a column and writing a formula. So let's say we wanted a percentage. I'll click the divide and I'll do 49. And now this, if I click apply, has calculated homework 1 divided by 49. And it's giving me a percentage, right? Because I have even listed total points as 49. I included that whenever I make a column. So this is a formula and it automatically evaluates. There's no filling down and there's no ability to get this wrong when you fill down. I found that can happen in Excel pretty easily. And so that is the formula editor. You can use that for any column and you can make very complicated formulas this way. Now there's another way we can make formulas in JMP, which is called instant formulas. That is, I can grab a column in the dataset, right click, and there's a new formula column option. And let me take you very briefly through these. If I go to the transform, notice we can do transcendental functions, we can log them, we can exponentiate, we can do aggregation type options. That is, we can grab several columns and calculate an average. So if I grab homework 8 and homework 9, let me right-click, new formula. Notice I can combine them to make a sum, a difference, take the ratio, take the average. So this will write a column formula for these columns. I can do distributional observations or distributional actions. I can center them. That is, take the observation minus the mean for each row. Standardize, that's z-scoring a column, take the observation minus the mean divided by the standard deviation. I can do something called a range, that is a range from 0 to 1. The lowest observation in the column will get a 0, the highest observation in the column will get a 1. It's basically a percent of the difference between the lowest and the highest. And then some other specialty options. And so let me just show you one of these. I'll take homework 9, let me right-click, new formula, distributional, and I'll standardize. And let me actually take both of these. I'll go to Analyze Distribution, and let's see what it did. It simply rescaled the distribution. Remember, standardizing doesn't change the shape. We're not normalizing anything. We simply took a column that had previously a mean of 51 and a standard deviation of 21 and gave it a mean of 0 within double floating point accuracy and a standard deviation of 1. So observations are in the same location in the distributions. We've just given them a common mean and standard deviation. So something that often we do when we have vastly different scores or distributions of scores on different assignments. All right, so those were instant formulas. There's a version of an instant formula called a temporary formula. That is, I can go into a platform and I can right-click a column and transform here. So let's say I wanted to do a standardized version of homework 1 inside of this launch window. That's a temporary formula. It's actually not stored to the data set, but I can still use it in an output window. And so I can transform at will. But what I want to show you are the sort of the formulas we most need for calculating new variables. And certainly averaging assignments and dropping lowest scores, those are ones that we do most. But we have a couple of things we have to do ahead of that. Notice that for each of my homeworks, these are on different number of points. So the first homework was 49, the second was 69, the last was 52. So before I take an average of these, I'm going to want to get a percentage for each of the columns. Well, you saw how I could do that. I can actually make a formula and divide each by the total number. But then I have to do all this manually, and my big rule in Jump is if you have to do something manually over and over, you can probably come up with a faster way. And so what I've been building, and I'll show you how to get to this on the Jump user community, is an add-in called Gradebook Tools. And so you'll see I have a lot of add-ins stored to my Jump here. Add-ins you can simply double-click and installs right into Jump. But one of the Gradebook tools that I built is just like the instant formula, specialty new formula columns. And one that I think is really useful is % of max. And with those columns selected, I'm going to click % of max. And notice what Jump did is it wrote me 8 new columns, where what it did, if I right-click and go to formula, it actually did the thing that I did before. So took the original score divided by the column maximum of that column. So Jump will look into each column and divide by the maximum score. And so this assumes that somebody got the maximum score, the total. I always told my class that if nobody gets the maximum, I'll always score percentage out of whatever the highest score is. So this one works for me, for my situation. Hopefully it can work for you. So what we have now is 8 columns that are the % out of the maximum observed score in each of the different columns. And from here is where I would create an average. I can just grab them all, right-click, new formula, combine, and take an average, right? And so this would give me the average of the percentages of those different homework scores. But you may remember I said one of the things in my class that I do is I drop the lowest 2 homeworks. And so we actually want to take these columns, so homeworks 1 through 8, the percentages, and I want to drop the lowest 2. Now dropping the lowest 1 is actually something that's fairly straightforward to write into a formula. Dropping the lowest 2, I don't know if you've done this in Excel before, it's a little more tricky. So again, that's under Gradebook Tools, new formula column, and I have a drop lowest K, so lowest number of columns that you specify. And so here's how this works. It'll ask you what number of columns to drop. I'll say drop 2 out of the selected 8. And we have to do something with those columns. We can take a sum, which doesn't make a lot of sense with the percentages, but we can do an average. An average does make a lot of sense. And so I'll click OK. And so my lowest dropping 2 here for each student, notice each one is higher, right? The average for any student will be lower than the average of the lowest dropping 2. And so each student does a little bit better here. And so that's my average column. I'm going to delete the original average. So now I just have this average of the % max, and that's what I want for my homeworks. Well, what about my final exam raw score for my midterm 1 and midterm 2? Well, let's do the same thing just so we can see it again. Let's do % of max. So new formula column, % of max. And I get those columns. Now in this case, we actually want to do a weighted sum. The final in this case was out of the sort of exams part of the class, the final was worth 40, and the 2 midterms were worth 30. And so let me show you how I would do this, the weighted average. I'm going to let Jump write the average column for me. So with them selected, I'll do combine and do an average. And so that calculates a formula. So if I right-click that column and go to formula, right, this is the formula, the mean of these 3 things. Here's actually my favorite way of doing it. I'll just take these times 0.3 and plus this one times 0.3 plus this one times 0.3. So we need a sum in this case. And my final 0.4. There we go. And now we have our weighted average here. Okay, so now that we have these different sections, we can actually make our final score. So we have, if I scroll back here, the average of % for our homeworks and the average for the finals. And we'd have to go and consult our syllabus to see how these things get added together. And let's just say that these are actually worth just as much. So grab the 2, right-click again, new formula, combine, and take an average. So the average of the averages here. If I show a distribution of this, this is actually always useful to do. Let's look at how our class is distributed. 80% or so on average, with a standard deviation about 10. We have a very long title now for this final grade column, as this is something I'll show you how to change in a second. We'd want to make sure, though, that there's no students with an extreme score, so nobody who's down here at 10 or 15%. That would, of course, indicate some kind of error we'd want to look into. All right, so let's rename this column. This has gotten pretty ugly. I just double-click. Now the column name has all those sort of averages of averages of averages, and we'll just say this is final grade. And let me click OK, which is now hidden itself. There we go, final grade. Now there's one final thing we haven't done. So calculating a letter grade. Now once we have this final column, we can do a number of things actually using column formulas. And if you've done final grades in Excel, you probably noticed that you can do it using if statements. Now, building an if statement for all the different letter categories can take some time. And so that is the last thing I built into this Gradebook tool here I want to show you. Under New Formula column, there's actually a Generate Letter Grade section. And so this is something you can do once you have that final column selected. Click on Generate Letter Grades. And what it'll bring up is a little dialog box that asks you first what the input column you're providing is. Is it a value out of 100 or is it a percentage column? And so in this case, it's a percentage column. That is, it's 0.6 or 0.56, right? If we actually had added these up and you're working in whole numbers, so if this said 56, you'd want to do value out of 100. And here are just some standard baseline cutoffs. And these depend on whatever you're using for your grading scheme. But the way this works is if a student achieves exactly or higher than this value, then they get that letter grade. And so 0 through 60 becomes an F, 60 through 63 becomes a D minus, etc. So when I click OK, what JMP will do is actually write to the data set that letter grade. And if I right click on here, let's go to Formula. And notice what it did is it literally created this as a column formula. And the way an if statement works is it evaluates forward here. It checks first if the grade is less than 60. And so if it's 60, they actually get the next grade up. So if it's less than 60, it's an F. Less than 63, it's a D minus, right? Unless it's less than 60, in which case it's F. So you see how the if statement is actually evaluating. If none of these criteria are met, that means that they actually got higher than a 97 or 97 or higher, then they get the A+. And so those letter grades, of course, you could have changed when you launched the original output. So that is our final letter grades. And so in actually not too many steps, we've gone from merging the data, importing, merging, detecting errors, creating new variables, and now writing out a final letter grade. Now, if we needed to save this out to upload to, let's say, a campus CRM, remember you can simply grab the columns you want. I'll grab this final column, and here's where you can do tables. And I haven't shown you this before, but this is quite useful, subsetting. So with the columns you want selected, we can actually subset and say, just give me the selected columns and make me a new table. So when I hit OK, this is a simplified table that then we can upload or provide to somebody. And remember, file export on the Mac or file save as on the PC will allow you to save this out as a simple text file or an Excel file if that's what you want. All right, so that's the basic tools. Now, before we get to the last little assessment piece, I want to show you some basic data organization tips because this has gotten to be a pretty ugly table. First, we have a lot of columns that actually just go into calculations, but don't really provide much value to us otherwise. And so for instance, the homework. And so I'm going to do something here called grouping. I'm going to right click and I'm going to say group these columns, which will put them behind a little fold. And so now I can actually rename this group and I'll say homework raw. Another thing we can do is grab that group and hide them. So now they're not shown in the table. Hiding columns means that they're not provided in the actual table output, but they are still available if we go to a platform. Notice that they're still available when I go to a launch window. We can also right click and do exclude. Excluding columns, and notice what that looks like. Excluding has the little X and hiding has the little mask. Excluding means that they're not shown now in any of the launch windows, which is actually quite nice. We have fewer to look through when we're actually looking in platforms. We could do the same thing for the percent of max for the homeworks. Take them all, I'm going to group those, and I'm going to hide them and exclude them. And so now they're not shown in the table, they're not shown in launch windows, and they're actually grouped in our table. So I'll say percent of match for the homework. There we go. So I'll put those right next to each other. I could do the same thing for the finals and exams, or the same thing for the averages, but notice already our table is looking a lot cleaner. And so, especially when you're working with large number of grading columns, I highly encourage you to do that. Now, one final thing I'll note, and this comes up when you have students coming by office hours and they want to look at their scores, you can grab a row in the table, just double click it, and that'll bring up what's called the row editor. And so the row editor actually shows you for each of the different columns in the table their actual scores. And so what's handy about this is you can minimize the rest of the table and show a student just their scores. Nice, because you don't want students to see everything else in the table. And so a row editor is actually a nice way to just look through just one row at a time. And again, you just double click a row and that'll pop open the row editor. All right, so that's basic data organization. Now, before we finish and take some questions, I want to show you rather quickly WebAssign and individualizing data sets. So a quick process for that. Now, first, WebAssign. If you just visit our website, you can click on the WebAssign link, and you can actually look through the questions that WebAssign uses. And these are nice. They use interactive jump output. And if you've ever used WebAssign, you know that they collect your scores and they'll aggregate them. And those are things you can save out and now update into your jump data table. And so that's one way to go about scoring with a class. Now, another way is individualizing data sets. And this is, again, something that's really useful when you have large classes, but you want to provide separate data tables for each student. And the workflow, there's a number of steps, but it's actually fairly straightforward. And I'm going to go through it a little quickly, but this is, of course, going to be recorded and provided so you can do this with your own. Basically, you start off with some original data. That is, choose some data that you want to do an analysis with. For instance, you want to have students regress height onto weight, but you want them to do it on their own data. So if we're looking at the original data, it might look like this, height by weight. And what you want students to do is fit that regression line and provide the slope and the t-value. So the slope here and the t-value. But that's on the main data set. You actually want students to do this on their own data. And so what we're going to do is actually create individualized versions of this data set. And we're going to do it through an add-in called Sampling with Replacement. And again, this is available on the user community, and I'll point you to that in just a second. But Sample with Replacement, if I launch this add-in, the way it works is it asks for what columns you want to include in the final table. I'll say all of them. And it asks you what the sample size you want to be is, plus how many samples you want to generate. Well, let's say I have 150 students in my class, and I want to generate Sampling with Replacement, a data set that has 40 observations per sample. When I click OK, JMP builds this table of 6,000 rows now, and that is the 150 tables all in one. So sample number 1 is here, sample number 6, sample number all the way to 150. There's 40 rows per sample. So what we're going to want to do now is actually perform that analysis, that regression, separately 150 times. Let me show you how that looks. I'll use analyze, fit y by x. I'm going to say do height, regressed onto weight. But we're going to use a special part of JMP called the by section, and we're going to put sample number in here. Because what that's going to do now is produce 150 separate outputs of that analysis, each with their own data, since every data set is slightly different. Now, to get the 150 regressions, we're going to go to the red triangles and fit a line. But I want to do that all at once. So if you're on the Mac, you'll hold down Command. If you're on the PC, you'll hold down Control. Then click the red triangle, and then click Fit Line. And what JMP will do is go through all 150 of the samples and fit a line separately for each one. We're going to finally ask the students about the parameter estimates. So to get a table that has all of those answers, because what you need to do is keep, of course, the correct answers, right-click the table, make a combined data table, and what that'll do is pull out in separate rows these different columns. So notice that we have for each sample 2 rows, one for the intercept, one for the weight, that is the slope, and we have the estimate, standard error, the t-ratio, and p-values. And if we just right-click the intercept, select matching, right-click the rows, and delete the rows, we actually now have 150 rows with the answers to our question we're going to ask the students, the estimate and the t-ratio. All right, so we just did all the analyses. So that's step 3. But we actually have to create individual files to distribute, right? This was the original table. We've made a resampling of that, and we did the analyses. So there's the resample table. We actually need to save out 150 different tables. And this is normally kind of annoying, but under Gradebook Tools and export individual data sets, I've written into this add-in basically the ability to grab the columns you want for the individual tables and then provide a dataset identifier. That is, I can say sample number, a table that identifies or a column that identifies the different samples. And so what I'm going to do is make basically a section on my desktop. I'll say data tables because I need to save 150 of these. I'll click OK, and JMP's going to ask me where to save 150 data sets. I'll point it to that folder I just made and click OK. And what JMP's going to do is go through actually each individual number of that column, the data set, and notice now we have 150 data tables that we can save out. And so this I would actually provide to students and give them a number that corresponds to their ID or something like that. And so they would use their own table. All right, so now we've made the individual tables. We need to collect responses from students. You can do this through Canvas or your campus CRM. I actually did this through Qualtrics, and so I had a survey built that was, just for their final exam or just for their midterm, and they would enter in the values that I actually asked them for. Again, because this takes a little work, I would do this just for high stakes questions. And then now, once you've collected those answers and downloaded them to your computer, you have to grade them. And again, what you've built now is a grading table. That is the thing we got from FitY by X when we used the by variable. And we have the student response table. And so this is just a simplified version with the slope and the t ratio. All right, so using what we've done before, what we need to do is update this grading table with the student response table matching on the basis of their data set number. Because notice what that'll do is it'll match the questions and their answers against the correct answer that we just built. And so let's try this. Tables, update. I'm going to update against that student responses table and match on the basis of, in this case, the sample number. Sample number matches dataset number, right? Because sample number is what I used internally. Dataset number is the answer I had them put on the exam because I assigned them to a dataset. So I had them just put in the number of the dataset they used. I'll say those match, and watch what happens is that my grading table now matched the data set to the sample. It has the student ID, so I know which student each of these corresponds to, and I have their answers to the slope and to the t ratio. Now, how am I going to grade those? Well, I'll take the slope and take the estimate column. I'll select them both. Those should match, but notice that students are a little bit variable in how many decimal places they used. Even though I told them to all use 4, some students don't know how to round, but that's okay. I always give a tolerance. And so let's go back to the Gradebook Tools. New formula column, let's do a comparison column with the tolerance. That is, compare these columns, but tolerate a little bit of difference. And we can do that as an absolute difference if you want to say within 0.10. I like proportion difference, so I say a student's answer is the same if it's within 2% of what the correct answer should be. And this question was worth 2 points, and so I'll say if it's correct, that is within the 2%, give them a value of 2 in a new column. If they're wrong, give them a 0, and I click OK. And notice now the students who are correct all get 2s. Here are some students that are wrong. So a 0, this person put in 0.44444. It should have been 0.19, so that just is very wrong, etc. For the t ratio, do the same thing. Select those 2 columns. Gradebook Tools, new formula, comparison column with tolerance. For this one, let's say we can allow an absolute difference of, let's say, 0.10. So for some reason, I want to use an absolute difference here. And this one is worth 4 points. So I'll click OK. And so again, if they get it right, they get a 4. If they're wrong, they get a 0. And so this is a nice way to do this grading rather quickly. And remember, we would update our final table with maybe the sum of these points. So right-click, new formula, combine, take a sum. And this is maybe the total score for the exam, at least for the take-home questions. So take-home questions total. And that's what we would update our final table with. All right, so that's a quick and dirty way to do individualized data sets. Let me show you where to get these tools. And so to do the Gradebook Tools, basically if you go to the JMP user community, so community.jmp.com, and look for Gradebook Tools, here's what it looks like. Version 0.03 just got posted. I added on some additional features there, but you can go, just click to download this, and when you double click it on your computer, it'll add into JMP right away. Same thing with sample with replacement. You can get that on our JMP community, and I'll also be sending out a link to this journal, and I'll just include the add-ins actually with the journal I sent out today. All right, so to find the recording of this webinar, if you visit our website, so I'll send it out to all of you today, but if you are interested in where to get our webinars or to get more of them, if you click on Academic Webcasts on our website and click on over into the Academic Webinar Library, you'll see a listing of all of our recordings. And this webinar, again, is called JMP for Grading and Assessment, and it's no longer just coming soon. I'll actually put the video and the journal and the actual add-in links all right here. All right, so I think I went a little bit long here, but I'll see if Ruth has any questions from any of you, and I'm happy to stick around and answer any of those that you have.